In this video, we will be talking about solving rational equations for a specified variable and applications of rational equations. Looking at this first example, it says the focal length f of a lens is related to the distance an object is from the lens, s1, and the distance the image is from the lens, s2. By the following formula, 1 divided by s1 plus 1 divided by s2 equals 1 divided by f. Solve the equation for s1. So we're going to start with this equation, and in order to solve for s1, we have to get s1 out of the denominator. So just like we've done in previous videos, we're going to start by getting a common denominator. So S1, S2, and F are all distinct factors. So the LCD will have all three. S1 times S2 times F. And we need to make all the denominators look like that. So this first denominator has S1. It needs S2 and F. Same thing in the numerator, S2 and F. The second denominator has S2. It needs S1 and F, numerator and denominator. And the last denominator has F. It needs S1 and S2. Now that all the denominators have S1, S2, F, S1, S2, F, S1, S2, and F, we can clear the denominators, clear out those fractions, by multiplying everything by the LCD. Now let's look at what's left in the numerators. So S2 times F times 1 is just S2 times F. And 1 times S1 times F is S1 times F. And 1 times S1, S2 is S1, S2. Now, I want to solve for S1, which means I need all my S1s on the same side. So I'm going to go ahead and subtract this S1F and move it to the left-hand or right-hand side of my equation so that all my S1s are on the same side. This means S1F minus F1F is 0. I'm going to bring this up here. I have S2 times F left on the left-hand side, and now S1, S2 minus S1F on the right-hand side. Now here's kind of the tricky part. I have an S1 here and an S1 there, and I need to have just a single S1. So these two are being multiplied. They have S1 in common. It is a common factor, and I can factor that out. So I divide out S1, and I'm left with S2 minus F. So now I have a single S1 that I can get alone. So I have to get rid of this factor of S2 minus F. I'm going to divide both sides by S2 minus F. That whole quantity has to stay together. And now I have S1 alone. S1 equals S2 times F divided by the quantity S2 minus F. So there you go. So we clear out the denominators to get rid of that rational expression or equation. And then once we have all the denominators cleared out, we make sure that S1s are on the same side. We've factored out the S1 and divided away everything else. Alright, that was part A. Part B says if you use a 50 millimeter camera and the image distance is 60 millimeters, at what distance should the object be to achieve the best photograph? So that's what this equation was all about. And we just have to make sure we're plugging in the right information into the right place. So that 55 millimeters, that's part of the camera. That's the focal length of the camera. So F is 50 millimeters. And then the image distance was 60. So the distance the image is from the lens, that's the image distance right here. That was S2. So S2 is 60 millimeters. Now we plug it in. We're going to go ahead and use this equation that already had S1 solved, right? S1 was the distance from the object, and that's what we're trying to find. So I'm going to leave it as S1 equals, S2 was 60, F was 50, divided by S2 is 60 minus F, which was 50. In the numerator, 60 times 50 is 3,000. In the denominator, 60 minus 50 is 10. And then 3,000 divided by 10 is 300. And there you have it. Go ahead and try the next two examples of rational equations. The next example says a utility company burns coal to generate electricity. The cost C is dollars of removing P% of the smokestack pollutants is given by C equals 80,000 times P divided by 100 minus P. The first question says, is it possible for the company to remove 100%, that is P equals 100, of the pollutants? So we have to look at the equation here. If I plugged in 100 every time I saw P, what would happen? In the denominator, we'd have 100 minus 100. Can we divide by 0? If I plugged in 100 for P, I would get 100 minus 100 is 0. We can't divide by 0. It's not possible. So no, it's not possible to remove 100% of the pollutants. Alright, part B says solve the equation for P. So we're starting with C equals the 80,000 times P all over 100 minus P. So it's a rational equation. We need to get a common denominator. It's a little bit easier this time because on the left-hand side the denominator would be 1. We can put any whole number over 1. And so we just have the one denominator of 100 minus P. We still want to make them common. So I'm going to multiply by 100 minus P on that left-hand side. So now they have a common denominator. I can clear out my denominators and look at what's left. On the left-hand side, I have 100 minus P times C. And on the right-hand side, I have 80,000 P. Now remember, we're trying to get P alone. So what we need to do here is get all the P's on one side. It doesn't do me any good to have a P on the right-hand side and a P on the left-hand side. So I'm going to have to distribute to get that P out of the parentheses. So now I have 100 times C minus P times C. And again, I need to get all my P's on the same side, so I add PC to both sides. I have 100 equals 80,000 P plus P times C. And just like we did on the last problem, I have P is a factor here and P is a factor here. 80,000 P and P times C have a common factor of P that I'm going to factor out. So I take out the P, I'm left with 80,000 plus C now. And if I were to distribute that back through, I'd get back to where I started. And lastly, I need to divide both sides by that 80,000 plus C to get P totally alone. And that leaves me with P equals 100 divided by 80,000 plus C. So we've solved that rational equation for P. Alright, the next example says the function C equals 5t divided by 0.01 t squared plus 3.3. Describes the concentration of a drug in the bloodstream over time. In this case, the medication was taken orally. C is measured in micrograms per milliliter, and T is measured in minutes. We want to know, what does the point 40, 10.4 represent? So remember, the first coordinate in our pair here is always the input. It's the independent variable. So when I look at this equation and I want to know what the input is, well, that's T. I can input different times and I would get out C. So that first part is T. And remember, time is in minutes. So that says that at 40 minutes, we want to know what's going to happen. So the second part of our coordinate is the dependent variable. So depending on what we put in here, it's going to affect the output. In this case, the output is C. I plug in values of T, I get out values of C. And C was in micrograms per milliliter. So that says at 40 minutes, there will be 10.4 micrograms per milliliter. Per milliliter in the bloodstream. So that's what that point means. So just breaking down about what's the input, what's the output. The first part of our coordinate is the input, the second is our output. And part B here says approximately when is the maximum amount of the drug in the body. So that means the maximum, we want the highest point, so somewhere around here. And remember, the x-axis is our input, the y-axis is our output. So again, this x-axis was the input, it's going to represent the time. So if we want to know when, we want to know when this highest point is here. Somewhere about there. I bring it straight down. So maybe about 18 minutes. Because we remember that time was in minutes. So this is just taking a rational equation and seeing if you can decipher what it means.